How is it, everyone? And welcome to your first class maths tutorials. And in this tutorial, we're going to have a look at a question on joint variation. So the question reads, the mass of a wire varies jointly with its length and the square of its diameter. 500 meters of wire of diameter 3 millimeters has a mass of 31.5 kgs. What is the mass of 1 kilometer of wire of diameter 2 millimeters? So basically, when you look at a problem like this, you're simply going to formulate your equations using the concept of joint variation. So for us to write the statement, or for us to just list the parameters that we have in this question, we've got mass as a parameter, and we've got our mass in kgs, and then we also have the diameter, right, in millimeters, and we also have the length of the wire, right? So here, if you look at this statement, which is saying the mass, which is represented by the letter M in this scenario, the mass of a wire varies jointly with its length, L. We're going to take L as our length, and this one is our diameter, right, as its length and the square of its diameter. So the square of its diameter, in this scenario, the diameter is represented by the small letter d, but we need the square of its diameter, meaning to say the d that we have, we are going to square it. So this is the statement. From here up until here, we can express it in the form of joint variation. So this statement is simply saying the mass of a wire varies jointly with its length and the square of its diameter. This is what is being stated by this statement here, right? So if you look here, you have got some parameters that you already have, like the mass here, I mean the meters. The meters is going to be our length. So here we already have 500 meters as our length, right? And then the diameter, we've got 3 millimeters. And then the mass, we've got 31.5 kgs. So the question which is posed is, what is the mass of 1 kilometer of wire of diameter 2 millimeter? That is the question which is being posed. So if you look here, we can simply say mass is equals to LD squared. In this scenario, there's no need for you to introduce a constant, because at the end, you are going to formulate two equations, and those constants are going to cancel each other. So basically, there's no need to introduce a constant in this scenario. So now, if you look at the mass that we've got 31.5 kgs. So we are going to say 31.5 kgs is equals to, what is the length that we have? We've got 500 multiplied by, what is the diameter? We've got 3 diameter squared. So we are going to square that one, the diameter. So this is going to make our equation 1 to answer this question. And then we are going to formulate another equation, because in this scenario, you've got other parameters in the last statement, which is saying what is the mass of 1 kilometer of wire of diameter 2 millimeters. So if you look here, the 1 kilometer, it is the length which is already given. So if you convert 1 kilometer into meters, it is going to be 1000 meters. And then another thing that is given is diameter, which is 2 millimeters. So we also have the diameter of 2 millimeters. So what is required is the mass. So if we say M is equals to, we are going to take this equation as well. What is the length? We've got 1000 meters multiplied by what is the diameter? 2 squared. This is going to make our second equation in order for us to answer the question. So now if you look at this situation, we are now going to divide, right, equation 1 by equation 2, right? So if we divide, so it simply means divide equation 2, we need to divide this equation 2 by equation 1. This is what we need to do. So by dividing, we are simply going to have m over 31.5 kgs is equals to, then here we are going to have 1000 multiplied by 2 squared over 500 multiplied by 3 squared, right? So these formulas or these equations, we simply formulated them so that we can find the mass which is required. So here if we simplify 500 into 500, 500 into 200, it's going to give us 2, and then 2 squared is 4, 4 by 2, we are going to have 8, and then 3 squared over 9. So we are going to have m over 31.5 is equals to 2 squared, 4, 4 by 2, 8, 8 over 9, 8 over 9, right? So the value now of m, it is going to be, we are going to do the cross multiplication so that we've got m equal to 8 over 9 multiplied by 31.5. But still, here after multiplying m with 9, we are still going to divide it. So it will eventually come back here. So the value of m, the mass that we need, is supposed to be 8 over 9 multiplied by 31.5 kgs, which is going to give us 28 kgs. So this is how you calculate the mass of a 1 kilometer wire, which has got a diameter of 2 millimeters. So this one was a bit complicated, but not necessarily complicated, but it's one of the questions that you must always look out for when it comes to joint variation. This is one of the questions which you must understand, especially in terms of formulating equations and then finding the mass which is required for a different length of wire, and also that wire with a different diameter. So always remember that practice makes perfect. And some of you might ask why we didn't introduce the constant, but I think I've mentioned it earlier in the tutorial that it was not necessary to introduce the constant k, just because it was eventually going to cancel each other and become one. So the main problem here, or what we were required to find, was the mass of a 1 kilometer wire with a diameter of 2 millimeters. So by formulating those equations using joint variation, you will be able to compute the value of mass which is required. So always remember, practice makes perfect.